Alright, this is going to be a video on logarithms and their rules or laws. So, and this is pretty much what I talked about on Tuesday before Thanksgiving, so many of you may have missed this and may want to watch this video to pick up on what happened. So, we talked on Monday, the day before this, yesterday, about how to solve something like 7 to the x equals 11. And we used the change of base. Wrote this in, say, base 10. So 7 is 10 to the log 7. Because this says, to what power do you take 10 to get 7? So this is some power that you can take 10 to get 7. And now we're taking 10 to that power, and so we get 7. So that's 7 to the x equals, and then we're going to rewrite 11 as a base 10. 10 to the log of 11. Because this says, to what power do we take 10 to get 11? So ask for a power that you can take 10 to get 11, and now we're taking 10 to that power, and so that's 11. Now, since this has same bases, we can't cancel bases, but we can surmise that if they have the same bases, the powers have to be equal, and if the whole things are equal. So, and when we got a power to a power, we multiply, so we get x log 7 equals log 11, and to solve for x we divide by log 7, and we get x equals log of 11 divided by log of 7. Now, I chose to do it in base 10 because the calculator has log base 10. The calculator also has log base e. That's the natural logarithm. So, we could rewrite this as e to the natural log 7, because this says, to what power do we take e to get 7? So this is a power we take e to get 7, and now we're taking e to that power, and so that's 7. So 7 to the x equals e to the ln 11. Same reason, to what power do we take e to get 11? This is a power we take e to get 11. E to that power is 11. So this is another name for 11. This is another name for 7. So, since the bases are the same and these are equal, the powers must be the same. And we got a power to a power, so we multiply. We get x ln 7 has to equal ln 11. Divide both sides by natural log of 7. And we get x is ln 11 over ln 7. Now, looks like we got two different answers, but we don't. If we go natural log 11 divided by natural log 7, we get approximately 1.232 something. And what do we get when we do log 11 divided by log 7? That's log base 10. Exactly the same number. So, that's, this is going to be, let's go a little bit further here. So, if I had an equation like this, let's see, this is like some base to some power, let's say P equals some number A. Of course, this can be rewritten as a log that says, to what power do we take b, the base, 2 to get a, and that's p. The power that we take b to get a. And so one of our first log rules is how to change a power equation to a log equation, or a log equation to a power equation. Now, this also, what we've done here also shows us how we can change the base, and we come up with a change of base rule. If I change b to a different base, say base 10, this would be 10 log b, which is another name for b, because to what power do I take 10 to get b? 10 to that power is b, so this is another name of b. To the power p is, and change this to base 10, 10 log a, and we get the powers, since the bases are the same, the powers must be equal, and this comes down times, and so we get p, oh, not equal here, p log b has to be equal to log of a. So if we divide by log of b on both sides, we get the power p. The power p has to be, let me write it here, p is log a over log of the base b. So we have this rule for, since this, the solution for p in this is this, by what we were doing up above, we know that this can be changed to this. Now I chose 10 here, but this could have been base e and the log base e, or it could have been 7 and 7, so it could be log in any base, so any new base c. So this is called the change of base rule. We can take the log of a base b and change it to log of a base, a new base, over log of the base in the new base. For example, I'll use this change of base rule to actually show how I can I'll take an equation that I know. 2 to the third equals 8. A simple one that I know. This says, to what power do I take 2 to get 8? And I know the answer to that's 3. But the change of base rule, since I don't have base 2 in the calculator, I only have base e or base 10, I can do this on the calculator by saying log base 10 of 8 divided by log base 10 of 2. Log of this divided by log of this. And this changes to the base 10. So I'm using the base 10 rule. And if I do log 8 divided by log 2, close parenthesis, I get 3, what we knew it was. But I could do this into any base. I could do it in base e, ln 8 divided by ln 3. So I'm changing the base from 2 to e, by 2. And I should get 3 also. So let's try that. ln 8 divided by ln 2. And that's also 3. So I've just applied the change the base rule to do this. So we have power to log, log to power equation. And then we have change a base rule. Now, next I want to go to some other things here. And we're going to do this. First of all, I want you to realize that the order of operations, which say parentheses, exponents, multiplication, division, addition, subtraction. And that's kind of a hierarchy. The lowest on there is addition and subtraction. Above that is multiplication and division. And above that's exponents, or powers. Now, logs were invented before calculators to aid us. Now I want to just kind of show you a little bit of why. For instance, if I had, let's just take some simple problem that we know how to do, like 3 times 7, and you know the answer to that's 21. But let's use the change of base rule. Let's change this to base 10. So 3 is 10 to the log of 3. That's log base 10 of 3. Times 7 can be 10 log 7, and that should equal 10 log 21. Now, this is a multiplication problem, second tier level of there, but when you're multiplying with the same base, what do you do to the exponents? Well, multiplying, like x squared times x to the third, you get x to the fifth. You add the exponents. So here we're going to add the exponents, and we get 10 to the log of 3 plus log 7 has to equal log 10 to the log 21. Now, if they got the same base, this part must be the same. And so we're seeing a rule here starting to emerge. It says the log of, in both of these in the same base, log of 3 plus log of 7 turns into the log of 3 times 7. So our log rule is log of A plus log C in any base turns out to be in the same base, log B, of the two arguments multiplied, A times C. Often we use it the other way. The log of two things multiplied is log of A plus log of C, but it can go both ways on this. And so this is the sum of the logs equals the log of a product. And you notice we've changed a multiplication problem to an addition problem. We've lowered the hierarchy one level from multiplication to addition. Now what happens when you divide? Let's say 21 divided by 3, which we know is 7. If we do the change of base rule here, and change to base 10, we get 10 to the log 21 divided by 10 to log 3, and we know the answer is 10 to the log 7. Now what do you do when you divide with the same bases? Like x to the fifth divided by x to the second. Well, two of these x's cancel two of those, and we get x to the third. Or we take, since of the same base, we can take 2 from 5 and get 3. We subtract. So this division becomes one less lower power subtraction. This becomes 10 to the log 21 minus log 3 equals 10 to the log 7, or the log of 21 minus the log of 3, just that power has to equal that. And so we get the division rule for logs, or the subtraction rule. Log in any base of A minus log in any base of C equals the log in that same base, these same bases all the way through, of A divided by C. Okay, so this is the difference of logs is the logs of a quotient. The quotient goes to one lower, subtraction. Multiplication goes to one level lower, addition. What about exponents? Do they go to one lower, multiplication? Let's see. So let's say we have the problem, something we know, 2 to the third equals 8. And we've kind of done this before, but let's see what happens here. So let's go to base 10. So we got 10 to the log 2 to the third equals 10 to the log 8. And what happens here? So we know this has to equal this. So this becomes down here as becomes multiplication. So 3 log 2, we multiply the powers because something to a power, you multiply them, is log 8. But log 8 is log of 2 to the third. So we have this power of 3 goes out and becomes multiplication. So an exponent becomes multiplication on the outside. So our rule is, if we have log in any base b of a to some power c, I'll say, the power can be dropped down in front, c log a in base b. So there is our power rule for logs. So if you have watched this video to pick up on this, let me know by sending me a text or an email, and I will give you credit for watching this video as if you were in class on Tuesday. And if you were on class on Tuesday and you watched this video, I will give you double credit for being on Friday. Thank you.